everyone. I'm Lindsay Lewis, editor of Building Enclosure. Thanks for joining us today. On August 26th at 2 p.m. Eastern Time, we have a free webinar, Future-Proofing Buildings with Whole Building AWBs. Our presenters, Andrea Wagner-Watts, Building Science Education Manager for GAF and Siplast Building and Roofing Science Team, and Benjamin Meyer, Building Enclosure Business Director with Siplast, are here with us today to talk about what to expect during the live presentation. Andy and Ben, thanks for sitting with us.
Absolutely.
Thanks for having us.
So to kick off, why is resilience becoming a core priority in modern building design, particularly in light of increasingly severe weather events?
So it's a great question. So I think resilience kind of gives a framework that allows a project team to, code is the minimums we have to start with. But looking at resilience allows you to say, well, what are the risks are we going to face with this project, and kind of build your own adventure around, whether it's additional weather or it's fire, or what risks might you have based on the design, whether you have an area that might collect a lot of water, so if additional rain may impact you more severely based on your design and your location. So it kind of gives a kind of a broad framework to get more specific about the things that a project really needs to focus on.
Now, can you explain the difference between simply meeting code requirements and minimums and designing to actual performance criteria for resilient buildings?
Yeah, so taking what Ben said is, when we talk about resilient design, we really focus on a very specific location and a very specific building type to understand what the needs are to keep that building functioning after some of these big events happen, like rain, heavy rain or flooding or fire. The code, especially at the national level, the National Model Building Code, is taking a broad swath across the entire country and saying, what do we need to make sure that these buildings stand? Not that they withstand necessarily any of these big events, but that they stand and are safe. So the building code starts from from a safety standpoint and sets that baseline minimum. And then when we look at resilient buildings, we're looking at how we take that baseline minimum and not only make it a safe building, but also make sure it can remain occupiable, it can remain inhabitable after some of these severe weather events.
Now, if we're looking at air barriers, what characteristics should architects look for when selecting air barrier materials?
Yeah, and it kind of comes back to that as an example of when you're trying to meet the code minimum as an air barrier, the goal is that the material stops air movement, and there's tests that demonstrate that. But in reality, in practice, your project conditions are really going to tell you where you need to focus. So if you're building in an area that has, pop-up rainstorms every day, that's going to tell you that you're going to need a material that can withstand wetting if you're putting a liquid on, immediately after application. So you're not having to do it over again, or you compromised, the performance of that building for the rest of its life. On the flip side, if you're working on a building that maybe you're doing in small segments, or it's a retrofit or a large rehab, and you're kind of working in small sections, things like a peel and stick or a self-adhered might be really good because it allows you to start and stop very easily. You don't have any waste in the bucket if it's a liquid. So all of those things are super important to get an effective application, but they go way beyond just looking for the code minimum specification requirement. So those are really where the materials and the application come together, and the designer has to kind of be aware of that. It's really part of the project scope in terms of knowing, the phasing and how it's going to work from a construction perspective.
So I guess if we're expanding on that a little bit, how do whole building air barrier assemblies contribute to a structure's overall resilience?
So if we take that baseline minimum, we're trying to prevent air. Well, air doesn't come by itself when it moves through space. It brings with it heat and it brings with it moisture. And so when we're talking about resilience and remaining occupiable, one of the big things we often look at is, how do we keep our building occupiable if the power goes out? So we want to keep our heat in, and one of the easy ways to do that is to make sure we're not having all of this unintentional air and warm air either escaping if we're in a cold climate, or coming in if we're in a warmer climate, to keep that space more comfortable long term. And we also want to make sure that we're not getting extra moisture into our space that could potentially result in biological growth in our walls and in the assemblies that could ultimately degrade our materials faster.
So during the live webinar, will you be sharing any findings from real world projects that highlight the performance benefits of these modern assemblies?
Yeah, we'll go through some pretty specific examples of, how when you specify, whether it's a material kind of above the standard code minimum, or you take into other considerations around maybe water resistance or UV resistance, how that turns into performance in the field, and how to even consider that for a project from a real world perspective. When we talk about, UV is a great example. We look at, for air barriers, most purposes tend to be, temporarily exposed during construction and then get covered up on the wall side. What the impact of that looks like overexposure or underexposure. What does it actually mean to be UV exposed in an open joint assembly? So all those are very nuanced and specific, but that's what, from a project perspective, those things you really have to consider to actually get the performance you want out of materials.
Now, how does whole building air tightness testing validate performance? And will you be covering that at all during the webinar?
We definitely will be talking about it a bit. Whole building air tightness is designed to make sure that whatever materials and assemblies have come together to complete the whole building air barrier are installed to actually perform that way. So it's a way to validate the installation and the ultimate performance, not just in a lab, not just under perfect conditions, but the way it was installed on that project site. And we want to make sure we're doing that so that at the end of the day, when the project is turned over to the building owner, that owner then is getting what they've paid for and what they've come to expect in a building that's going to last them a long time.
I wanted to ask about building enclosure commissioning a little bit too. What role does that play in ensuring that a resilient design actually performs the way it's intended to?
Yeah, I view kind of enclosure commissioning almost as an enabler. If the goal is, we have to meet code, and then you also want to consider, what specific impacts, that this project needs to have that's going to make it resilient. Building enclosure commissioning becomes kind of that enabler that lets the owner kind of describe what they're worried about, what conditions, they know about, and then kind of communicate that across the project team, through the architect, through the enclosure commissioning agent and the contractor, all the way through the process from design to construction and even post occupancy. Do we hit our goals? So it's really a way that you can kind of benchmark and make sure that the project owner gets outlines what they think they want, describes what they want, and then gets what they want at the end, so that it can actually be resilient. That can be part of the goals of the project.
Lastly, I do want to ask, what else will attendees learn on the live day?
Oh, I think they'll learn a lot. So I'll let Andy speak, for herself as well. But I think they'll learn that, I'm a bit of a nerd. Like, these are the things that get me excited around, what makes buildings perform, what details make the buildings work. So I think we'll get into a lot of that, and bring the questions, because we'll go deep.
Yeah,
Andy.
Yeah, I was gonna just add to that this presentation will get into specifics. You should be able to leave this presentation with key things that you can put in your spec to make sure you're getting exactly what you want at the end of the day. If some of these attributes that we talk about, you do want to incorporate on your next project.
Well, thank you again, Andy and Ben, for your time today.
Absolutely.
Thank you.
To register for this free webinar, head to continueducation.bmpmedia.com. Until next time, visit us on buildingclosureonline.com for your educational and technical resources.